Okay, so I thought we'd look at Pythagoras Theorem. Because I'm old, I was always taught that the square of the hypotenuse is equal to the sum of the square of the other two sides. So we had to learn that off para fashion. Okay, now we don't need to do that. It's just written as a squared plus b squared equals c squared. Okay. Now, this is only for right-angled triangles. And directly opposite the right angle is the longest side of the triangle, and we call this the hypotenuse. Okay, this is ancient Greek for the word stretched. So this longest side is the hypotenuse. So this is always C. The hypotenuse is always C. The other two sides, I've marked this up as A and this up as B, but it doesn't really matter. This could be A and this could be B, because in the formula you're going to add them anyway. But what's important to remember is that you're squaring them. Okay? So if we take probably the most famous Pythagorean triangle, so let's say this side is 3 centimeters and this side is 4 centimeters, and we need to find the length of the hypotenuse. Okay, so we know a squared plus b squared will equal c squared. So a is 3, so 3 squared plus b squared, which is 4 squared, equals c squared. Okay, so now we need to find out what these numbers are. So 3 squared is 9, plus 4 squared is 16, and this equals c squared. Remember, this equals c squared, not c. 9 plus 16 is 25, so this equals c squared. Now the examiners don't want to know what c squared is, they want to know what does c equal. So c must be whatever number multiplied by itself gives us 25. Okay, so the reverse of squaring something is to find the root. Okay, so we would find the root of both sides technically. So the root of c squared is c. So we need to find the square root of 25. So the square root of 25, now we know that it's plus or minus 5, but of course because we're dealing with measurement here, we can't have negative measurements, or not at GCSE level anyway. So we can say that C is 5 centimeters. Okay, so it's all quite nice and simple. So let's maybe do another one so you get the idea. So okay, let's say that this side is 5 centimeters. Sorry, I'll cross that out. Do that again, it looks like 6. So this side is 5 centimeters, and let's say that this side is 12 centimeters, and they want to know what C is. Okay, so we know a squared plus b squared equals c squared, so in the exam make sure you write this because this is worth 1 mark. So this would be 5 squared plus 12 squared, and that will equal c squared. Now 5 squared I know is 25, plus 12 squared I know is 144, and this will equal c squared. So I add these two together, that gives me 169, so that gives me c squared. Now remember, for me to find c, I need to find the root of 169. Okay, so usually this comes up on a calculator paper. Okay, but I happen to know that the square root of 169 is 13. Okay, so given that this is 12 centimeters and this is 5 centimeters, then this is going to be 13 centimeters. Okay, we're all okay with that. So sometimes you might get, let's change the numbers a little bit. Okay, they might give you some fairly horrible numbers, but let's say they keep it fair. So let's say this is 7 centimeters and this is 6 centimeters. Okay, so a squared plus b squared equals c squared, so that would be 7 squared plus 6 squared equals c squared. So 7 squared is 49 plus 6 squared is 36, and this equals c squared. So I add these two together, so 70, so I would get 85. Okay, and that would equal c squared. So remember, c would equal the root of 85. Okay, now here you would definitely use your calculator. I don't offhand know what the square root of 85 is. It's going to be about 9 point something. Okay, so we get 9 point whatever it is equals c. But that will give me the answer. Obviously you would use your calculator for this, okay, and then you could find an exact answer. And usually here, this is where they will ask you what is your answer to so many decimal places or so many significant figures. Okay, so what I'm going to do now is I'm just going to pause the recording and we'll look at finding a side that isn't the hypotenuse. Okay, so we're back now and we have a slightly different question. Okay, so we know the length of the hypotenuse here. Normally we would be looking for it, but this time we know it. We also happen to know this side, but they want us to find this side. So this formula is what we use, but we need to rearrange it so that we get what we want. Now I would urge you, rather than putting the numbers in straight away, is to rearrange the formula first. Okay, so we want b, okay, we want this value. Now we know A and we know C, so all we do is a minor piece of basic algebra, which is to find B. B is positive where it is, so we keep it here. B squared equals, and the A squared is going to move over. So obviously remember the signs change. So B squared equals C squared minus A squared. Okay? So now we've done that, we can put our values in. So we have B squared equals C squared. Now C squared is 12 squared minus A squared, which is 8 squared. So now it's just arithmetic. So B squared equals 12 squared is 144 minus 8 squared, which is 64. So B squared will equal, now 144 minus 64 will be 80. So we want to know B. So that's going to be the square root of 80. Okay. So if I just tap that into my calculator, square root of 80 is 8.94. So we will get 8.94 centimeters. That will be to 2 decimal places. So when you're doing this, always write Pythagoras Theorem out, rearrange the formulae so that you're in good shape to find out what you want, substitute in the values, and then do it in this step-by-step manner. I know, you probably could say, okay, 12 squared is 144 and go from here straight to this line, but examiners would like to see some sort of mathematical rigour, so they want to see why. Okay, this is important. So let's just make sure we've got another one for you to do. So let's take this out. Okay, but I'm hoping that you can see that it's fairly simple. Okay, it's just, again, like I've always said, it's just practice, nothing more than practice. Okay, so let's say this is 14.2 centimeters, and we'll give B a value, so we'll say this is 8.4 centimeters, and they want us to find A. Okay, so they'll mark it with an X. So we're looking for A, so we use A squared plus B squared equals C squared. So we don't know A, but we know B and C, so I need to get these together so the B squared will come over. So I'll have A squared equals C squared, because that hasn't moved, minus B squared. Okay, so now it's just a question of substituting in values. So A squared equals, now C is 14.2, so this is 14.2, and this is squared, minus B squared, which is 8.4, and that's squared as well. So A squared equals, now 14.2 squared, 14.2 squared gives me 201.64. So this is 201.64 minus Now I've got to have 8.4 squared, 8.4, and we square this, and we get 70.56. 70.56. Okay, so a squared will equal, so now I've got to subtract 1 from the other, so 2.01, so 201.64 minus 70.56 gives me 131.08, 131.08. Okay, remember this isn't the answer, we have to find the root. And if you think about it logically, this side here couldn't possibly be 131, so that should be an indicator. So a will equal the root of 131.08. So a will equal, and I'll just put that in, 131.08 gives me 11 point, well, to 2 decimal places will be 11.45 centimeters. Okay, and that would be the answer. Okay, so as I say, I hope you can see that it is fairly simple. This formula here is golden. You need to know this. A squared plus b squared equals c squared. I believe it's not in the cheat sheet at the beginning of the exam paper, so you would need to memorize this. Okay, but it's a tiny formula. Okay, and remember it only applies to right-angled triangles. Okay, so again, just practice, revise, and you'll be fine.